Sure, yeah.
Yeah, yeah, may as well.
I mean, we talk about agentic orchestration, means like integrating AI features in solutions, but is it safe to do it like this? Or do we have some concerns to take care about, especially when we are in a regulated company? And that's what we're going to talk about. Huge work has been done by the community on the AI governance framework. Berlin, thanks for coming once again.
Cool,
You're
no worries.
a regular speaker with us. Happy to have you.
Cool, thank you very much. So yeah, I've managed to attract a bit of an audience with agentic AI and then scare some people away with governance. And I think I've got the right balance and roughly the right number of people in the room. So that's a good start. So, oh yeah, so some people spotted governance and they're going to leave now. Anyway, I'm Colin Eberhardt. I'm the CTO of a software consultancy called Scott Logic. We're UK based and we predominantly work within financial services. And I have a bit of a cough, so I might die halfway through this. So yeah, like many of the people in this room, I see AI as fundamentally an incredibly transformational technology, but there are definitely some risks. Some of them quite significant, especially as we start moving towards agentic AI, where we're effectively handing over more autonomy to these tools. So yeah, I want to talk about this amazing technology, but I fundamentally want to talk about some of the steps we can take to hopefully use it a little bit more safely in our day jobs. Now it's, yeah, just checking it's advancing. It's pretty much standard practice in a lot of conference talks to do a brief history of the thing that you're talking about. You know, if you're doing blockchain, you do the brief history of blockchain. So I thought I could do the brief history of AI. I think that would probably take the rest of the day and possibly most of the night. It's moving so quickly. So for a bit of fun, I'm just going to do a brief history of just the last 4 weeks of AI. And let's see if we can keep up with that. So it was around about a month ago that OpenAI released GPT 5.1. It's now got a couple of models. It's got the instant model and a reasoning model. Again, it increased performance on various different benchmarks. It was a pretty decent release. Just 3 days later, Google released Gemini 3, their latest foundational model, beating OpenAI on every single benchmark possible. They also released a new product called Anti-Gravity, which is effectively their vibe coding platform. And 1 day later, someone managed to undertake an exfiltration attack on Anti-Gravity. In terms of the technical details, it was pretty simple. It was using MCP, and they basically said to Anti-Gravity, oh, can you collect up the secrets from their .env file and send them to this particular URL because we really need it. That was pretty much the extent of the attack. Interestingly, Anti-Gravity will not read your .env file because that's part of the security policy. So it wrote a script to read the .env file. Amazing. That was a day later. And then a few days later, someone on Reddit complained that Anti-Gravity had deleted their whole hard drive. Amazing stuff. Oh, and they actually asked, did I give you permission? It thought for 25 seconds and went, no, you didn't. I'm so sorry. I mean, I know this is quite funny, but what's quite good here is that the tech industry are front running some of the problems that you will be experiencing yourselves with this technology. Okay, we're about 3 days in. The day after that was the release of Claude Opus 4.5, which beat both Gemini and GPT 5.1, smashed the benchmarks. This one is SWE-bench, software engineering benchmark. The improvement on that benchmark is unbelievable. The model performance is doubling it, and I think it's every 7 months on that particular benchmark. The rate of progress is quite astonishing. You might have heard about sort of training having hit a wall or scaling no longer providing the gains that it used to. It's not really the case. The benchmark performance is still going up and up and up. It was only a few weeks ago that Google provided Nano Banana Pro, an oddly named image model, but this one really took the world by storm. It's been a viral sensation for its ability to create really hyper-realistic images. It's pretty amazing. Amid all of this, OpenAI have recently internally announced a code red. For the first time, I think, in their history, they are starting to get really concerned about the competition. And I think this is predominantly competition from Google. Google have data. They have their own chips. They have platforms that they can integrate AI into. And OpenAI are in a bit of trouble, I'd say. Then this guy did a bunch more deals. So Nvidia, I'm not going to go into their deals. They're mind-boggling. They've got so many zeros I can't keep up. I think this guy has basically discovered the economic equivalent of a perpetual motion machine. It's an astonishing feat. On a more interesting and practical note, there's been some interesting survey data that I've seen recently. This one's from OpenRouter, that basically have a product that sits in between the large language models and the applications that you or I develop. I'd encourage you to go away and have a look at the whole report. It's really interesting. But one of the biggest takeaways is that programming has really taken off in a big way. The use of large language models for programming has increased from 11% to 50%. And the bottom axis isn't even a year. That's been a massive spike. And it does very much validate the way that the foundation model developers are focusing on that particular use case quite a lot at the moment. Other studies, MIT published a study based on a thing they call the iceberg index, which is a massive simulation looking at the impact of AI on the job market. As is always the case, it got massively incorrectly misreported across the media. They basically pointed at it and said 11% of us are going to lose our jobs. That's not what the report said. It said 11% of tasks are at risk of being automated by AI, but a job is a collection of tasks more often than not a single task. But people like that kind of headline. And then McKinsey, in a kind of one-upmanship, declared that 57% of work tasks are automatable. Now, I do like making fun of these reports, and I like making fun of the misrepresentation. That doesn't mean to say I don't think they're good reports. I think they're very interesting reports. If you take a step back from the crazy headlines and actually look at the substance, it is really interesting and really useful to see at a high level where we're going to find this technology having an impact and where we're not. So I'd encourage you to ignore the headlines and actually read the reports. They're pretty good. And then just a few days ago, as was mentioned here earlier, the Agentic AI Foundation was created. This is an open source location for things like MCP, agents.md, and so on. And again, a further maturing of the open source part of the overall story. So that was the last 4 weeks in AI, or the bits that I can actually remember. There was probably a whole load of other stuff. But yeah, it's without a doubt, this technology is moving at an incredible pace. But let's take a step back and ask ourselves why. Why is it moving at such an incredible pace? Now, AI has been around for years. It's been around for 30, 40 years. In fact, one of the first things people started doing with computers was trying to create artificial brains. AI is as old as the computer itself. But there are a few things that changed just a few years ago. You'll have no doubt heard of generative AI. So generative AI was a new type of AI model. It's a model which generates, in its original kind of instantiation, it's a model that generates text based on a prompt. However, once this was created, there are a couple of features of it that really made it take off in a way that other forms of AI haven't. The first is it became a general purpose model. And what I mean by that is previously there were models for doing things like text processing and so on, but they were specialized. If you wanted to do sentiment analysis, you'd get a model trained for sentiment analysis. If you wanted to do, for example, summarization, you'd get a model to do exactly that. Or if you wanted a model to do something that hadn't been done before, you'd have to spend months training and creating that. You don't have to do that anymore. If you want summarization, you go, ChatGPT, summarize this. If you want classification, you go, hey, Claude, classify this stuff. It's a general purpose AI model. It can do all sorts of things without you having to train, design the architecture, and spend months developing it. It can do so many things. The next one is pretty much linked. It's a human language API. Prior to GPT-2, 3, and so on, the API, the application programmable interface for these, was typically in Python. So if you wanted to do something with AI, you either had to be a Python developer or be friends with a Python developer. And they're quite a nice bunch. So that's fine. Whereas now, you don't need that Python developer anymore. You just write in human language what you want it to do, and it will do that thing. That's pretty amazing. And it's a combination of those two features is what I believe has really accelerated AI, or at least this particular type of AI. But then there's more. That those two facts occurred around about 3 years ago, but then some really interesting builds happened on top of them. The first one is the reasoning capabilities, and you might have heard that it described as emergent. What that basically means is they were able to start creating reasoning without having trained the model to reason. They found that this behavior, as the term suggests, it emerged. It was unexpected. The next one is the use of tools. People started experimenting with finding ways to allow the large language model initially to search the internet, for example, but then through things like MCP, we're connecting these things to anything and everything. So combine all of these, general purpose AI models, human language API, reasoning capability, use of tools. I think it's the composite of these four things, which is causing this to be, I would say, the next technology epoch. And I've got a fairly simple definition of what a technology epoch looks like. It's try to explain to your kids what the world was like before that technology. It's really funny talking to my kids about the simplest thing of, oh, how did you arrange to meet people back in the old days? Well, you'd arrange a time and a place. What happens if they didn't turn up? They didn't turn up. That was it. That's the world that we used to live in. It's incredibly hard for the generation that's grown up with GPS and mobile phones to actually wrap their heads around what it was like. I think another 4 or 5 years' time, there'll be a generation that's grown up with AI who will really struggle to understand what the world was like before this technology. And to me, that's a technology epoch. The iPhone, for example, the internet were technology epochs. And now we're moving into the agentic era as well. That's further causing this to be a significant technology transformation. So what does this mean in the context of business? The interesting thing here is the extent of impact of this technology. Most technologies typically have an impact in one part of the business or the other. AI has very far-reaching implications. Some of them are risks, some of them are opportunities, and these span offerings. So these are the products that your business produces and sells to the wider market. There are no end of opportunities for adding AI capabilities and features. But also, it has a potential impact on your operations. It has an impact on how you fundamentally conduct your business processes. Again, this is an area where agentic AI is of significant interest. But also, looking back to the MIT and the McKinsey study, it has an impact on your people as well. It has an impact on the jobs that they do, the tasks they perform, and the relationships they have with each other. And fundamentally, it has, combining the people and operations, it causes you to rethink the way that you actually get things done within your organization. You might need to reshape some of the processes based on where AI will integrate. And again, this is highly unusual. We didn't get this with the iPhone, for example, or the tablet. The extent of impact is huge. So this is an amazing technology full of incredible capability and potential, but it has some very surprising limitations. Now, you've probably heard of hallucinations. So hallucination is where an AI system will confidently assert something to be true when it isn't true. And if you have a greater knowledge than the AI system, that's something that's typically fairly easy to recognize. You'll have probably heard of prompt injection attacks, where people come up with creative ways to subvert the behavior of the AI model. Unfortunately, hallucinations, prompt injection attacks, there isn't a solution yet for either of those limitations of these systems. Everything that we're doing at the moment, in the face of those, is a mitigation and a minimization. There isn't a solution to either of them. However, I think there's an even more fundamental problem of these systems once you start using them in agentic systems. So it's a thing that I haven't got a pithy name for it, but it's large language models don't know what they don't know. They have a very poor understanding of their own capabilities and a very poor understanding of their own limitations. And I'd like to give you a demonstration through Lego. Does anyone else like a bit of Lego? I'm like, yeah, yeah, good. We're all big kids. I was building some Lego with my son. I was building some Lego. He was watching, and I took a photo of it. Just took a photo of the pieces and said to ChatGPT, "Hey, what could I make with this Lego?" And it came up with some really good suggestions. It looked at it and went, "Okay, some greys, whites, yellows. You could make a starship or a robot." I thought, "Oh, that's pretty good." So I said, "That's great. What about the starfighter? Can you create a picture of it and then maybe some instructions?" So it created this picture of a starfighter, which again looks really good. And then it provided me with some instructions. Those were the instructions, and that's what I built. Incredible, isn't it? Yeah. So this is the problem was the large language model had no idea that the ask that I had made of it was far beyond its capability. I would give that a 1 out of 10, if that. So ironically, I said, "How did you perform on this task? How good or accurate do you think your instructions are?" And it gave itself a 70 to 80% mark. So I think over optimistic. And you will see this time and time again. I know this is a silly example, but try it yourself with ChatGPT or any of the chat interfaces. If you ask them to do something that's far beyond their abilities, more often than not, they will give it a go. I've tried this, for example, with the vibe coding platforms. If you ask it to, for example, create a sort of, I don't know, a word puzzle game, they will knock that out to the park. But my background is in trading systems. So I asked, I think it was Bolt or Lovable, I said, "Build me an FX trading platform with technical analysis, Bollinger Bands, moving averages." And it went, "Okay." And it created something which was ridiculous because it just doesn't know. And that is a massive problem and a massive limitation of these systems. So this gets us to a slightly uncomfortable truth. And the uncomfortable truth is that we don't actually know how these things work, which is a really weird thing to say about technology. And it's not the case that the people in this room don't know how it works. It's the case that nobody knows how it works, which is almost unique. Now, the best analogy here is our understanding of these is a bit like our understanding of human beings. So with these models, we can see the weights, we can see the architecture. With human beings, we can see the DNA. And more recently, thanks to AI, we know a little bit about how the proteins fold as a result. But we don't know how within human beings that leads to intelligence and autonomy. With the AI systems, we don't know how those model weights turn into intelligence and autonomy. Our level of understanding is not dissimilar to our level of understanding of ourselves. Some have used a term which I think is really good, that generative AI wasn't engineered, it was grown. It was grown through feeding an algorithm lots and lots of data and output this amazing thing. What that means fundamentally is we have to use this technology with a lot of care. So it might sound like I'm being incredibly negative here. I'm not. I'm being cautious. And I think there's a very, very big difference. I'm very optimistic about the promise of this technology, but you have to meet it with a level of caution. And the interesting thing about technology is that technology isn't of itself risky or non-risky. It's all about the application. It's all about how and where you're using it. And with this technology, and especially agentic AI, it all depends on where you're using it in the decision-making process. So this is a bit of a segue onto what we've been developing in FINOS. FINOS, FinTech Open Source Foundation, is a membership organization, part of Linux Foundation, that has a significant number of banking organizations as the members. One of the things that we did was a significant number of the banks got together with organizations like the one that I work for and started to build a governance framework for AI. And this, you might think, why is that the case? We already have governance frameworks for AI. The reason for this is, as I mentioned previously, generative AI is a very different type of AI to the AI that we had 4 or 5 years ago. And funnily enough, in a lot of organizations, a lot of organizations that are already fluent in AI, the first thing they did when they started to adopt generative AI was they looked to their existing AI teams. And the existing AI teams, their world is predominantly numeric, predictive AI. They've got mechanisms for model risk management. They looked at that and ChatGPT And there wasn't a very good match. We needed to create something new to accommodate the risks of non-determinism, hallucination, and so on. Now, I'm not going to dig into it in a great deal of detail, but I want to take a step back a little bit and talk about agentic AI, because that's what everyone is talking about at the moment. And the problem I have with agentic AI is, as with many things in AI at the moment, is it's a very poorly defined term, and that in itself is quite a problem. So the way that I think about it is agentic AI isn't a single thing. Agentic AI is a spectrum where on one end, it's not agentic AI. On the other end, it's definitely agentic AI. And then there's the messy bit in the middle. So looking at the spectrum, the first part is level one, applied generative AI. This is where you're not using an AI system for any form of decision making. This is where you're purely using it for generative tasks, summarization, rewriting, classification, that sort of thing. That isn't agentic AI. The next one is where generative AI is typically being used to perform a single goal, where it can take actions, but those actions are fundamentally constrained. So you can do X, not Y. For example, you might use it for a classification process where it is acting, but all it's able to do is classification. I personally wouldn't consider that to be agentic AI, but there are a lot of product companies who apply the label agentic AI to that type of usage because it helps sell. For me, agentic AI is the third level, fully autonomous AI agents, multi-step planning, tool use, adaptation. And the fundamental thing here is with an agentic AI system, you are giving it a goal and a collection of tools that it can use in pursuit of that goal. And then it is autonomously pursuing that goal through using those tools and through using its own reasoning. You are not telling it how to perform a task. You're telling it the goal that you want to achieve and giving it the tools that it can use in pursuit of that goal. And again, I think it's pretty amazing that we've got a system that is powerful enough to do that for us. But again, that comes with certain risks. Now, it's probably fairly typical to consider level one applied large language models to be low risk, level three fully agentic, goal-oriented to be high risk. Unfortunately, it's not that simple. The risk associated, there's certainly an increase of risk as you pursue agentic AI. However, the risk, again, is very much dependent on the type of thing that you apply the AI to. So I'm just going to rattle through a few quick examples. And again, these are going to be more from the financial services domain. So I'm hoping these are some processes that you're familiar with. So looking at applied generative AI, systems that don't perform any actions, there are low impact examples and high impact examples. And just to clarify my terminology, the impact I'm talking about here is not business value. I'm talking about the impact of failure. So the potential losses that you might incur, the risks. So low impact examples could be drafting communications, summarizing PDF documents, cleaning up notes, that sort of thing, where the risks are modest. It's typically the hallucination risks or misrepresentational risks, but their operational impact is limited because of the use case. However, there were some very similar sounding applications where the risks are much greater. For example, summarizing KYC, so know your client files, drafting compliance interpretation. The fundamental technology challenges are the same, but the risks are much greater because of the application. So for example, false statements incorporated into official records. Actually, this is where you've probably heard some of the cases of generative AI is being used quite a bit in legal cases. And there have been a great number where they have hallucinated prior legal cases, which is very similar to this kind of application. Also, there's a problem that often in these cases, you've got a human loop, that there's a challenge where the human overtrusts the generative content. We are fallible. The next is Gen AI assistants that are pursuing a single constrained goal. So they perform a predefined action with limited autonomy. So low impact and slightly safer examples could be categorizing customer inquiries or auto-tagging help desk tickets. So this is looking at the operational usage of AI. And again, this is the one where if you think about it, if it categorizes a ticket incorrectly, the worst impact could be you might be slow to respond. You might not meet the SLA for a particular client. That's not great, but it's not catastrophic. You could use it for things like automated updating of CRM fields, extracting data from invoices. And again, in the legal domain, using generative AI to analyze documents and speed the processing is really good. The risks are wrong classification, poor data quality, potentially bias as well. But again, there are high impact examples that on the surface look quite similar. So this could be triggering steps in a critical business process. So know your client is a very critical business process within financial services. It's going to be risky to apply this technology to actually make sit at a decision-making point within that. Auto-responding to customers. Again, you're upping the risks because you don't have a human in the loop. Screening for anti-money laundering, for example. So here, the net result is that you can make incorrect decisions or false anti-money laundering alerts, that sort of thing. Then finally, fully autonomous AI agents. And again, you might think, is there any safe way of using this technology at all? Well, there is potentially. And again, these are systems that pursue goals, not tasks, with significant autonomy. So low impact examples could be internal research agents. I use it for research quite a lot. I really like ChatGPT deep research. It is very good at doing a sort of skin deep, quick review of a particular topic. I mean, I've done this when I'm my day job is consultancy, and I've used deep research, for example, when I'm going into a meeting with a particular client to actually research the client and some of the individuals. And it does a great job of giving me a bit of a briefing. And again, it doesn't matter if it's not right, as long as I review it and am mindful that it may not be entirely accurate. Another low impact, incredible application of agentic AI is in software and coding agents. And as I stated previously, that field is really taking off. And as an example, I've been using a tool called Devin, which will work autonomously for many hours if you provide it with a suitably well-defined goal and a suitable set of tools that allow it to evaluate its progress. So again, the risks, multi-step hallucinations can accumulate. And again, with my software developer hat on, if you give it a goal and it starts to go in the wrong direction, it can go really off the rails. And it can drift from the intended behavior and so on. But then there are high impact examples, end-to-end customer onboarding, fraud investigation agents. Basically, high impact examples are pretty much taking any critical business process and just giving it to an agent and saying, hey, you do that. And I don't think I even need to enumerate the risks here. Now, I was talking about the risks. I want to talk about some of the mitigations, some of the controls. I don't want to go into all of the details. So I just want to talk about what I consider to be probably the three most important things you need to do with AI systems or agentic AI systems. The first one is testing. This is probably the most important mitigation, quite simply ensuring that the system does what you want it to do. Now, testing in software, or at least automation in testing in software, has always been relatively hard. I'm afraid it's actually harder with non-deterministic systems. What you have to do is, I don't know if you've heard of evals. So basically evals are a way of effectively doing a fuzzy check as to whether something is the same as your test data. And actually, just for fun, there are a lot of vendors downstairs that have agentic AI platforms. Go and ask them, what tools do you have that allow me to test and validate this agentic AI system? Most of them don't have an answer to that question yet. I'm hoping they will do one day. The next one, observability. Basically, to put it simply, this thing will do things in production that you've never seen it do before in test or dev. Models drift. Things change over time. The data that you feed your system will change over time. And you need to observe it. Then finally, possibly the most powerful mitigation is put an expert in the way, put a human in the loop. Now, this feels like a perfect mitigation. At least I thought it must be. Unfortunately, it's not. And again, taking coding as an example, these systems can produce content far faster than we can realistically validate ourselves. And a lot of us are under business pressure to use these tools, use these systems. Within software, people are really struggling with the burden of reviewing the output of these systems. And I'm quite confident that software quality can be eroded as a result. So don't consider this to be the perfect mitigation, but it is one of the primaries. So finally, yeah, I hope I haven't scared you too much. In all honesty, I do think this is the most transformational technology that we've seen. It's both wonderful and scary. It's wonderful that it can do things that we never dreamed that it would ever be able to do. And it's scary that we don't know actually how it's doing that. But yeah, go forth, enjoy, and exercise with care. Thank you.